Our next functional group is the carboxylic acid. Carboxylic acids are acidic, and they are very important. They also often have common names rather than systematic names. We're going to be learning the systematic naming system. However, you should be aware that there are very common traditional names, such as formic acid. Formic acid is the acid used by ants to fight off predators. Formic acid has this chemical structure. Really, it's just a meth. There's one carbon there. This is a methane attached to a carboxylic acid. And what this becomes is meth, and because there's only single bonds in a methane, methanoic acid. Likewise, acetic acid, the acid that makes vinegar vinegar, is known as ethanoic acid. It's really this, except boop, like that. So let's look at the priorities of carboxylic acids before we get into the naming. Carboxylic acids are our number one. Nothing has a higher priority than the carboxylic acid. There are times, however, where there will be a prefix used. We likely won't run into that scenario, but you should be aware that the prefix is carboxy in the case that we cannot use both. The suffix for this is going to be oic acid. Makes sense, they're carboxylic acids. They are acids, so they would be called an acid. The drawing for this is going to be, let's just draw ethanoic acid. We're going to have a ketone attached to an alcohol. That's really the structure of the carboxylic acid. So let's look at our examples. Let me get out of the way so you can see the whole thing. We'll look at our examples and we'll use these priorities to make sense of them. The first example we have here is just a straight carbon chain. Nothing fancy, nothing special. For this one, our carboxylic acid is always going to be our number one carbon, just like we did with aldehydes. So we've got a 1, 2, 3, 4. So this will be a butan. And then, naming the acid, oic acid. Excellent. For the next one, this is going to be a lot more complex. Again, our carbon number 1 is going to be where the carboxylic acid sits. So this will be our 1 no matter what. Followed by 2, and then we just need to figure out which of these carbon chains is longer. This will be 2, 3, 4, 5, or 2, 3, 4, 5, 6. This one's longer. This will be 3, 4, 5, 6. And this is our side chain. So in this organic compound, I have a hexanoic acid. So let's write that here. Let's just make a list of our functional groups first. Hexanoic acid. And then I've got a ketone right here on number 3. So I'm going to have a 3 and then a ketone. Normally, I would have the -one as my suffix. But since this is going to be a functional group that has a lower priority than my carboxylic acid, I'm going to use the prefix for the ketone, which, if you remember, was oxo. So 3-oxo. Okay, good. There's nothing else special about it. I don't need to do anything else to it. Here, number 2, I've got a 1, 2, 3. That would be a propyl group. So on number 2, I'm going to have propyl. And then at the 4 carbon, I have an alcohol. Now again, this takes a lower precedence than the carboxylic acid. So my alcohol is going to get hydroxy. There we go. So now I can just put these together, remembering my alphabetical order. I'm going to have 4-hydroxy. and then 3-oxo, 2-propyl, hexanoic acid. Quite the long name there. So now this last one, this is going to be a little more complex. Because notice, I have my carboxylic acid right here, but then I have an aldehyde here. And remember, for both of these we've said that that carbon is number 1. This is where priority rules take over. Carboxylic acid is higher priority, so it gets the 1 carbon. 1, 2, 3, 4, 5. Now, do I continue going this way, or do I go towards the higher priority? Well, I'm going to go for the longest carbon chain. My priority here will just be a functional group. I'm still going to go towards the longest carbon chain. My ether right here, that's always going to be a side chain. I'm never going to go down 5, 6, 7, 8, 9. I'm always going to go this way. Okay, so 5, 6, 7, 8. So 8 is oct, so this will be octanoic acid. Again, we're just going to list out our functional groups. On carbon number 5, I have an aldehyde. Now, if we look back at our prefixes, because this aldehyde has a lower priority, I'm going to give it its prefix name. So it's going to be at the carbon number 5, and it's going to be formal. And it doesn't have any extra carbons here, so I don't need to add anything else to it. Then here, I've got this ether. So at carbon number 6, I have an ether. And that ether is going to be 1, 2, 3 carbons long. 3 carbons, that's prop. So that will be 6-propoxy. So then once again, I just put them in alphabetical order. 5-formyl, 6-propoxy, octanoic acid. So 5-formyl, 6-propoxy, octanoic acid. And there's our carboxylic acids.